Okay, we're recording. Here we go. Number 15 from the quiz. Okay, so 15 from the quiz was r equals 5 sine of 3 theta. I really wish I would have got some little polar graphs, because the polar graphs make it much easier, but whatever. Okay, so it is a sine graph, right? And so your first petal or peak will be at pi over 2 times b, where this is your 3 is your b. So the first peak will be at pi over 2 times 3, which is pi over 6. And then we have 3 petals. And so how far apart are they going to be? If you go all the way around this circle, it's 2 pi. And so they'll be 2 pi over 3 apart. So I'll have a petal at pi over 6, and then at pi over 6 plus 2 pi over 3, which will be, 5 pi over 6. And then I'll have another petal at 5 pi over 6 plus 2 pi over 3, which is 9 pi over 6, which means it's 3 pi over 2. And then 5 is how far you're going out, the length of each petal. Is 5. All right, so I'm going to do my best to draw this. We've got pi over 6 is the first one, which is, I don't know, about here. And I'm going to go out 5 units, so I'll just say that's 5, so I would put a dot there. I've got a dot at the pole, by the way, too. I have one at 5 pi over 6, which is about there. And I'll go out the same amount of units. And then at 3 pi over 2, which is down here. And then you just want to make these petals. And obviously it looks funky, but it's definitely easier when you have the polar graphs to do those things. But that one's that one. Textbook 528. 9. We're going to skip that one. That's a spiral. And the fact that it's negative just means it goes in the other direction. But yeah, let's just skip that one. You don't, right? You're not going to need to do spirals. I don't care. Number 23. Okay. So page 529, number 23 is factor the polynomial x cubed minus 16 into linear factors with complex coefficients. And so what, if you remember, if x equals a root, then x minus the root equals 0. And then the factors are all of those guys multiplied together, right? X minus r times x minus r times x minus r. That's factoring it, right? So what I need to do is find these roots over the complex numbers. So what I'm doing is I'm solving this guy over complex numbers. And so it would be an x cubed is equal to 16, right? And then you want to write 16 in polar form as a polar number, because 16 is rectangular. So it's like 16 plus 0i, where 16 is the real part, 0 is the imaginary part. Spoiler alert, r is going to be 16, theta is going to be 0. And I know that because it's a real number, it's a pure real number, and it's positive. But I'll show you the work involved just in case that doesn't make sense to you. R would equal square root of 16 squared plus 0 squared, which ends up with 16. And then your theta is, that's 16 right there, right? So your cosine of your angle is x over r, so 16 over 16, which is 1. Sine of theta is 0 over 16, which is 0. And putting those together, when is cosine of your angle 1 and sine of your angle 0? When your theta is 0. So 16 plus 0i in polar form is r cis theta, so 16 cis 0. That's polar form. So I'm going to rewrite that. So I've got x cubed equals 16 cis 0. Right? And then I'm going to let x be just any polar number. It's going to be a root, right? So that means r cis theta cubed is equal to, this is an r, 16 cis 0, which means r cubed using de Moivre's theorem. You're going to take that r and raise it to the power of the exponent, and then cis, and then multiply that exponent times your theta. All right, so I've got that. Well, for this to be true, your r cubed must equal 16, and are they that funky? Yeah, they are. All right. And then 3 theta is equal to 0. I'm going to rewrite this on the next page rather than squishing all this. So we have r cubed cis 3 theta is equal to 16 cis 0. All right, so for this equation to be true, r cubed must equal 16. So r cubed equals 16, which means r is equal to the cube root of 16. What is 16? That would be 4 times 4, or 2 to the 4th, right? And so there's a perfect cube in there, which means your r is 2 times the cube root of 2. And then the other thing that's true with this equation is that 3 theta must equal 0. So we've got 3 theta must equal 0. But if you remember from trig, when you have 3 theta, that 3 means that you need to go around the circle 3 times, 3 revolutions. Theta will be between 0 and 2 pi, and so 3 theta means you're going around 3 times. So that means that you are going to add 2 pi to get to the next one, and then we'll add 2 pi again, and that'll give us our 3 angles that we would hit going around the circle. So you got 0, you've got 2 pi, and then you've got 4 pi. Those are the 3 angles that would give you that. And then, of course, you've got to divide both sides by 3 to get theta. So that we have theta will now equal 0 divided by 3, still 0, and then 2 pi over 3 and 4 pi over 3. So that our roots, the 3 roots, are r cis theta, right? So 2 times the cube root of 2 cis 0, 2 times the cube root of 2 cis 2 pi over 3, and then 2 times the cube root of 2 cis 4 pi over 3. So remember, those are your roots. If we're going to write them as factors, all you got to do is go, okay, if those are my roots, then this guy factors as x minus each of the roots. So x minus 2 times the cube root of 2 cis 0 times, which, by the way, cis 0 is just 1, so the answer just has x minus 2 times the cube root of 2. And then x minus 2 times the cube root of 2 cis 2 pi over 3. and then times x minus 2 times the cube root of 2 cis 4 pi over 3, and then set that equal to 0. And then just so you know, the back of the book shows this guy, since cis 0 is just 1, then it shows this factor as just x minus 2 times the cube root of 2. It simplifies, so, and I'm not going to write the rest of them because it'll take too long, but that's that one. That is that. Just remember, factors are just x minus the roots. Okay, page 492. And it's number 19. Okay. Doo-doo. Well, that's a weird one. All right, whatever. Okay, they want you to graph theta equals -1. Okay, well, remember, that's just a line. And what would -1 be? All right, so here's what I know. I know pi over 2. I know this is pi. That's 0. Pi is about 3.14, which means pi over 2 is about 1.57. Yeah. And then this would be a negative pi over 2, which is about a negative 1.57. So if I'm graphing -1, I'm going this way, but just not going that far. So I don't know. What about like that? Straight line going through. I'm going to say this is theta equals -1. And your r can be anything, so that's why it's that straight line. That was weird. You'll see something like theta equals pi over 6 or 5 pi over 6, and it's just a straight line going through it, going in both directions. That one was just weird because it's just straight up -1. All right, page 506, number 5. They want you to graph on the complex plane 3.5 cis 75 degrees. Okay, so you're going to have a polar graph, right? I'll say this is a circle of radius 3.5. So I'll just mark on here, this is 3.5. That's your r, right? Your r is 3.5. I'm just saying that these are 3.5 units out, and then 75 degrees would be, what, about there? There you go. That's 3.5 cis 75 degrees. It's as easy as that. It's that point right there. You're going, because I'm saying you don't need the line, but I'm saying that this angle is 75 degrees. This pen is not working very, very well for me. And then your r, that length out, is 3.5. All right, that was 506, number 5. This thing got bumped. Okay, 506, number 12 on the quiz. They want you to find all the roots of z to the 4th equals 81 in rectangular form and graph it. All right, so I'm going to show you this in polar form because I think we'll give you a more complicated one than just 81. But anyway, all right, so you do this the same way that I did that other problem where 81 plus 0i is rectangular form, and let's put it into polar form so that it's r is equal to, spoiler alert, Your r is going to be 81. Your theta is going to be 0 because it's a positive real. Because, 81 plus 0i on, if that's 81, then there's your point right there. But your r, showing you all the work, is the square root of 81 squared plus 0 squared, which ends up giving you 81. Cosine of your angle will be x over r, so 81 over 81, which is 1. And then sine of your angle will be y over r, so 0 over 81, which is 0. And putting those two together, your theta is 0. So in polar form, 81 in polar form is 81 cis 0. And we want to solve this z to the fourth. So we've got z to the fourth is equal to 81 cis 0. I'm going to let r cis theta be a root, which means r cis theta to the fourth power is equal to 81 cis 0, which then means r to the fourth cis 4 theta will equal the 81 cis 0. And for this to be true, that means that r to the fourth must equal 81. And if r to the fourth equals 81, then r is equal to 3. And then the other thing that's true is 4 theta must equal 0. 4 theta equals 0, but also you got to go around 4 times. So, or 2 pi, or 4 pi, or 6 pi. Remember, because it's 4 revolutions, since it's 4 theta, 4 revs. Since it's 4 times theta, you're going to go around 4 times. So you keep adding. I added 2 pi, and I added 2 pi, and I added 2 pi to get to the next angle. And then you've got to divide everything by 4, and so your theta will be 0 over 4 is still 0, 2 pi over 4 is pi over 2, 4 pi over 4 is pi, 6 pi over 4 is 3 pi over 2. And so graphing them, the easiest way is to do your polar guys. I'm going to go to the next page so that I don't cram it. So that means your roots, your 4 roots are, in polar form, that would be 3 cis 0, 3 cis pi over 2, 3 cis pi, and 3 cis 3 pi over 2. This is the easiest way to graph them is when they're in polar form. I'm just going to say this right here is 3 units out, right? I'm going to say this is a circle of radius 3. And then 3 cis 0 would be here, 3 cis pi over 2 would be here, 3 cis pi is here, and then 3 cis 3 pi over 2 is right there. Yeah, and but then they wanted it in rectangular form. They want your final answers in rectangular form. And so 3 cis 0, remember this is truly 3 times cosine of 0 plus I times sine of 0. That's what cis stands for. And so that's 3 times 1 plus 0i, which means it's just 3. The 3 cis pi over 2 is 3 times cosine of pi over 2 plus I times sine of pi over 2, which means it's 3 times 0 plus 1i, which means it's 3i in rectangular form. 3 cis pi is 3 times the cosine of pi plus I times sine of pi, which means it's 3 times negative 1 plus 0i, which gives you just negative 3, and then 3 cis 3 pi over 2 is this guy, which is 3 times 0 plus 1i, which means negative 1i. Negative. Sine of 3 pi over 2 is negative. So that's a negative. And so then you end up with negative 3i. So those were your 4 answers for in rectangular form. You had 3, 3i, negative 3, and negative 3i. Those are your rectangular answers. So that's rectangular. And these were in polar form, just in case, because I don't remember which way we ask. I know some questions we ask you for polar form, and some of them we ask you for rectangular form. On this graph, this point was 3, this point is 3i, this point is negative 3, and this point right here is negative 3i. Just so you know. Remember that the y-axis is your imaginary axis, and then the x-axis or the horizontal axis is your real axis. So that's where those points coincide. All right. So that one was quiz 12. What am I on now? Page 526, number 8. All right, so same type of problem, but it'll be more complicated. Because like that last one I just did is much simpler. If you have a good understanding of what's happening, you wouldn't have needed to change that to polar form. But all right, but something like this you do need to. Okay, so page 526, number 8. And it wants you to find the 6/6 roots of rad 3 minus I. Okay, so that means I'm looking for z to the 6th is equal to rad 3 minus I. Right, I'm looking for z. I need to solve for z. I need to find those 6/6 roots. So what you're going to do is change this guy to polar form. So let's start by finding r. r will equal the square root of rad 3 squared plus negative 1 squared, which ends up giving you 3 plus 1, so rad 4, which is 2. You can do this either by drawing a picture. You got rad 3 and negative 1, so it's this angle here, where you've got a 2 here, and I didn't draw this right. Rad 3 and then a negative 1. I should have drawn it a little wider. The other way you can do it is go, okay, I know cosine of theta is x over r, so it's rad 3 over 2. And I know sine of theta is y over r, so negative 1 over 2. And when is cosine rad 3 over 2? That's a 30-degree reference angle, because it's a short triangle, even though I drew it like a long one. It should have been more like this. Sorry. Negative 1. Cross that out. There's my triangle. That's a better job. And so that guy is what? 11 pi over 6? Sure, positive, negative, yeah, 11 pi over 6, because it's a 30-degree reference angle. Okay, so that means that I'm looking for, this guy in polar form is 2 cis 11 pi over 6. And then remember the z to the 6th will be, I guess I should show it just in case if you guys don't understand what's going on. I'm taking z is any polar number, so r cis theta, and then I'm raising it to the 6th power. De Moivre's theorem says, all right, this means that this is r to the 6th cis 6 theta is equal to 2 cis 11 pi over 6. For this to be true, then r to the 6th must equal 2, which means r is equal to the 6th root of 2. There's no answers right here. That's fabulous. All right, you guys tell me if you see a mistake. Okay. 6 theta is 11 pi over 6, and we got to go around 6 revolutions. Holy crap. 6 revs. All right, which means I'm going to add 2 pi to get to the next guy. And I'm going to keep on adding 2 pi. All right, so I got 11 pi over 6. Adding 2 pi would be like 12 pi over 6, so 23 pi over 6. Add another 2 pi, which would be 12 pi over 6, so 35 pi over 6. Another one would give me 12, so 47 pi over 6. 1, 2, 3, 4. I need 2 more. Adding another 12 pi over 6 would be a 59 pi over 6. And then one more. 12 would be 71 pi over 6. These are some weird numbers, so I just want to double check that I didn't make an error. Page 526, number 8. Boop, 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 boop. I am golden. Okay. Yay. Perfect. Okay. And then 71. Yeah, 71, 59, 47. Okay, good. Yay. I know how to add in my head. All right. And then you want to divide each of these by 6 so that your thetas end up being 11 pi over 6 divided by 6 would be, that means it's over 36. You could also think of it as times 1 over 6, if that helps. And then 23 pi over 36, and 35 pi over 36, 47 pi over 36, 59 pi over 36, and then 71 pi over 36. And then you're going to just write your answers as r cis theta. So it's like the 6 rad 2 cis 11 pi over 36. And then 6 rad 2 cis 23 pi over 36. And the 6th root of 2 cis 35 pi over 36. Hopefully you guys see, because I have a feeling I'm going to run out of room and I'm not going to be able to write all the answers. 47 pi, it's a 40. Come on now. Come on. Undo. Now watch, it'll just start deleting crap that I don't want to delete. All right, let's try that again. Yep. 47 pi over 36, 6th root of 2, cis 59 pi over 36, and the 6th root of 2, cis 71 pi over 36. There you go. You have 6 roots, right? Those are your answers. These guys. There. Sorry, it's so smushy. I should have just gone to another slide. But there you go. That was 526, number 8. Hopefully we don't ask you for 6 roots. Holy crap, that's a lot. All right, 492, 46. All right, converting. All right, so they want you to convert the rectangular equation to polar form. So here's the deal. Rectangular has x's and y's, and polar has r's and thetas. So you can't have x's and thetas in the same equation. You can't have y's and r's or anything like that. You got to convert everything to r's and thetas. And this guy was what? 3x squared plus 3y squared minus 2x equals 0. All right, so what you're going to use to convert are these three things. X is equal to r times cosine of theta. Y is equal to r times sine of theta. And x squared plus y squared is r squared. That's what you're going to use to convert between these guys. So since these two have the same coefficient, I'm going to factor out that 3 just out of the first two terms, because then I've got an x squared plus squared, right? And we know x squared plus y squared is r squared. So this is a 3r squared, and then minus 2 times x, I'm going to replace it with r cosine theta. And done. Yeah. Just use those conversions and split it up. And there you go. That was 492.46. Page 520, 23. Okay. Page 520, number 23. All right, so it says cis 2 pi over 3 to the negative 2 power divided by 0.1 cis pi over 6 to the third. Okay, so what I would do is you're going to use a couple of rules here. You're going to use the power rule that says, there's an invisible 1 right here in front, by the way. There's an invisible 1. So 1 cis 2 pi over 3 to the negative 2 power is a 1 to the negative 2 power cis negative 2 times 2 pi over 3. All right. And then it's going to be divided by, I guess I'll still write it like that, and then a 0.1 to the third power cis 3 times pi over 6. Remember, we take r to the power and then multiply the power times the angle. All right, well, 1 to the negative 2 power, I mean, really, that's, here, I'm going to write it technical. It's technically 1 over 1 squared. 1 squared is 1, and 1 over 1 is 1, and so it just ends up being 1. So this ends up being 1 cis, negative 4 pi over 3. And then divided by, I'm going to write it that way, 0.1 cubed, which is, well, can I do it like this? This is 0.1 is 1 over 10, and then cubed would be 1 over a 1 with 3 zeros, and then cis, 3 pi over 6 is pi over 2. And then how you divide polar numbers is r divided by r, so it's a 1 over 1,000. So we're going to take the reciprocal of 1 over 1,000. And then cis, and then you're going to subtract the angles. Negative 4 pi over 3 minus pi over 2. And so 1 divided by 1 over 1,000 is just 1,000. And then cis, what is that? Negative 8 pi over 6, because I did 2 over 2, and then 3 over 2, which is a negative 11 pi over 6. I would accept that. Did it say anything about putting it between 0 and 2 pi? It didn't. Negative 11 pi over 6 would be going this way and almost all the way around, and then here, right, which is the same as pi over 6. And so the answer that the book gives is 1,000 cis 1 pi over 6, because they are coterminal. And then pi over 6 is in between 0 and 2 pi. So they're coterminal. Okay. That was 520.23, 507.21. Boo, 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 boo. Okay. Page 507, number 21 says, express the complex number in polar form. Negative 8i, they want you to write it in polar form. So when I keep saying spoiler alert, I'll tell you what I'm envisioning. This is what I envision. This is my real axis. This is my imaginary axis. So a negative 8i is here, because it's the imaginary and it's negative. This is negative 8i, right there, 8 units away from the origin or the pole, right? So that's why I keep saying, spoiler alert, your r is going to be 8, and then this time your theta, because it's a negative imaginary, your theta is going to be 3 pi over 2. But I'll show you how it works. So we've got your r is equal to, first let me say, negative 8i is truly 0 minus 8i. How's that? That's in rectangular form. Well, negative 8i is in rectangular form also, but I'm just making it more obvious of, okay, 0 is my real part. That's the real part. And then negative 8 is your imaginary part, right? And so that's how I knew that you're graphing the point 0, negative 8 on the complex plane. Yeah. All right, so what is your r? Your r would be the square root of 0 squared plus negative 8 squared, which would be 0 plus 64. So you're taking the square root of 64, which is 8. So your r will always be positive. I know that. And then cosine of theta is x over r, so 0 over 8, which is still 0. And sine of theta would be y over r, so negative 8 over 8, which is negative 1. And 1 is cosine 0, and y and sine negative 1, it's down here, and that means your theta is 3 pi over 2. And so the polar form, remember, is r cis theta. And so it's 8 cis 3 pi over 2 is polar form of negative 8i. Number 8 on the chapter 10 review worksheet. Review worksheet. All right, I gotta find it first. There we go. Okay. So review worksheet number 8. It says convert 3x minus 2y equals 1. convert this to polar form. And I, by the way, the directions on there just said convert rectangular to polar or polar to rectangular. How do I know that I need to convert to polar? Because you've got x's and y's, so this is rectangular form. That's rectangular form. And they want us to convert to polar form. And then, so I'll write these again. How you're going to convert them is x is equal to r times cosine of theta. Y is equal to r times sine of theta, and r squared is equal to x squared plus y squared. Sometimes you use them all, sometimes you don't use them all. In this case, we're only going to use the first two. I know x is r cosine theta, and I know y is r sine of theta. And on this one, you can actually solve for r. The other one I did, you had an r squared and an r, so that's the reason why I just left it the way it was. This one just has one r that's in common to both terms, so you can totally factor out the r, and you would be left with a 3 cosine theta minus 2 sine of theta, and then divide both sides by that craziness. So your answer would be r is 1 over 3 cosine theta minus 2 sine of theta. It's standard for you to solve for r if there's just one r in your equation, like that you could factor out and solve for r, and in terms of theta, that's usually how we write a polar equation. The time we don't is if there's an r squared and an r in it, we just leave it as is because you can't just solve for r. All right, that was the review worksheet, number 8. Where are we on now? 514, number 25. Okay. It says, give a geometric interpretation of multiplying by negative I. Yeah. By any complex number. Okay, so I'm going to let r cis theta be a complex number. And I want to know what happens when I multiply negative I by it. So I need to convert negative I, which is in rectangular form. This is equivalent to 0 minus 1i, right? I'm going to convert this guy into polar form. Right? And so, spoiler, r is 1 and theta is 3 pi over 2, but how I see that is negative I is here. It's just 1 unit away, and your theta is 3 pi over 2. But I'll show you just in case. We got your r would be square root of 0 squared plus negative 1 squared, which ends up giving you rad 1, which is 1. And then cosine of your angle is x over r, so 0 over 1, which is 0. And sine of theta is y over r, so negative 1 over 1, which is negative 1. And putting those together, your theta is 3 pi over 2. So in polar form, r cis theta, negative I is in polar form 1 cis 3 pi over 2. Okay, so what happens when we take just any complex number, I'm calling it r cis theta, and I want to multiply it times negative I, which we just figured out was 1 cis 3 pi over 2 in polar form, right? And so this would be, do you remember we multiply complex numbers by multiplying the r's together, and then it's a cis, and then add the angles. And so what that means, geometric interpretation, is your r stays the same, right? R times 1, your r stays the same. But here, you're adding 3 pi over 2, which means it's a counterclockwise rotation. Rotation 3 pi over 2. So whatever your angle is, you would go and rotate it counterclockwise 3 pi over 2. So if your number started at, if you were here, it would bring you to there. If you're here, it would bring you to come on. It would bring you to there. If you were, not that they have to be quadrantals, they could have been here, and then you're going to just go, go to there. I know that's more confusing than anything, but that's what's happening. You're taking that point and you're rotating it counterclockwise 3 pi over 2. So, all right, that was 25 on page 414. And so we're on page 520, number 11. They want you to use de Moivre's theorem to evaluate each power and then express your answers in polar form. So they want, rectangular form. Okay, so we got 3 plus I rad 3 to the negative 2 power. This would be ugly to do in rectangular. Really ugly, right? Plus it says use de Moivre's theorem. But you definitely don't want to do this with rectangular coordinates. So you're going to convert this guy to polar. Okay, so your r will be square root of 3 squared plus rad 3 squared. By the way, when you do these r's, you don't put I in it, right? It's just a squared plus b squared, and the b is the number in front of I, or multiplying times I. All right, so that ends up giving you what? 9 plus 3 is rad 12. That's 2 rad 3. So that's your r. And then your angle would be cosine of your angle would be x over r. So 3 over 2 rad 3. And you would need to rationalize that. So it would be times rad 3 over 3, which will give you a 3 rad 3 over 2 times 3. And your 3's cancel. Oh, yay! That ended up being an angle we know. I'll double check it. Sine of theta would be y over r, so rad 3 over 2 rad 3, which is a 1/2. And so when is your cosine rad 3 over 2 and your sine 1/2? When theta is equal to 3 over 6. All right, so converting it to polar means that this becomes a 2 rad 3 is my r, cis pi over 6, and we're raising it to the power of negative 2. And de Moivre's theorem says you're going to take that r and raise it to the power, and then take the angle and multiply it. All right, so what does that mean? That means this is a 1 over 2 rad 3 squared, and then cis negative pi over 3. Gotta go this way. Which is a 1 over 2 squared would be 4, rad 3 squared would be 3, and then cis negative pi over 3. Did they change it to a positive angle? Oh, they wanted it in rectangular form, so it doesn't matter. Okay. Cis, so I'll leave it as, I don't know. do you want to do? Do you want to leave it as negative pi over 3? If it was positive, it would be, I'll just write it. I'll say positive angle would be, what is that, 5 pi over 3? Okay, so I'm gonna box this just because if we asked for the answer in polar form, that's your answer. And I'm not sure if on this question, if we let you leave it in polar form or if we have you convert it to, this thing is really bothering me tonight. It's choking me. I don't know if we let you leave it in polar form or if we let you, or if we make you change it to rectangular form. So I'm going to go to the next page and convert these to rectangular form. 1 over 12, 5 pi over 3. Okay, so 1 over 12 cis 5 pi over 3 is polar form of the answer. To convert it to rectangular form, that's when we actually go, okay, cis truly stands for cosine of 5 pi over 3 plus I times sine of 5 pi over 3. And 5 pi over 3 is down here. That's a tall guy. So a negative rad 3 over 2 and a positive 1/2. And so we have 1 over 12 times 1/2 minus rad 3 over 2I. And then you want to just distribute the 1 over 12 on there. So 1 over 24 minus, I usually stick my I in front of the rad. I rad 3 over 24. That's what the answer they gave. They put the I at the end, whatever. I guess 1 over 24 minus rad 3 over 24I. This is truly A plus BI form. It's just usually common for, if there's an I and a radical, for you to stick the I in front of the rad. That's just what's typical in most math textbooks and stuff, but you can also put it in A plus BI form. All right, that was 520, number 11. Page 528, number 9. Somebody already asked that, and I said, I don't know it. You can always just do an X or an R theta table, but that's a spiral, and it's weird, and we're not going to do it. I'm skipping that one. Ooh, sorry. What else? I caught up to all your questions. I can't believe it. Worksheet number 6. Oh yeah, that's a good one, huh? That was quiz. Worksheet number 6. Okay. Oh, same type of problem. Perfect. Okay, so review worksheet number 6 says R equals negative secant of theta. And they want us to convert this to, since it's in R's and thetas, they want us to convert to rectangular, which means X's and Y's. All right, so what do I know? Here's how I would do it. I know cosine of theta is X over R. And I know secant is the reciprocal of cosine, right? So that means in terms of x's and r's and y's, secant is r over x. So let me rewrite that like that. This is a negative r over x, which means that now I can multiply both sides by x and divide both sides by r. And x equals 1 is the answer. Because I guess I skipped a bunch of steps, but I went times x so that those guys canceled, and then divide by r, you get x equals -1. What else? Nothing? So, guess I'll just do, pretty much went over like everything that you're going to see. I don't see anything that, oh, the graphs, huh? Hopefully you guys know how to do all the graphs. Nobody asked me, well, at the very beginning you had me do the one from the quiz, but that was it. Holy macaroni. Just remember, you know, polar coordinates will be r comma thetas. Rectangular coordinates are going to be x comma y. What else? Polar form of a complex number. I guess I should write that, of a complex number, is r cis theta, which really truly means r times cosine of theta plus I times sine of theta, right? And then rectangular form of a complex number means that it'll be a plus bi. And the things that you use to convert these things are what I just said about the whole x equals r cosine theta, y is equal to r sine of theta, x squared plus y squared is r squared. What else? If it's not a special angle, you might have to use the fact that tangent of theta is y over x, right? So you'll use inverse tangent there. That's just when it's not special. All the rest of the times, you saw me, I just said, oh, cosine of, hopefully you remember, cosine of theta is x over r, and sine of theta is y over r. Tangent of theta was y over x. We use those reciprocals for secant, right? I use the reciprocal of that guy, so you kind of need to know that too. And what else? If you are multiplying or finding the product, multiplying two complex numbers, then you'll multiply the r's, and add the thetas, add the angles. And when you divide two complex numbers, you will divide the r's and subtract the thetas. And then de Moivre's theorem was when it was to a power. If you have r cis theta to, I'll just use n, then what you'll do is you'll take r and raise it to the power, and then cis n times theta. So you'll take r and raise it to the exponent, and then the exponent times the angle. And so you saw, even if we give you a rectangular complex number, easiest way to change it to polar, raise it to the power, and then do that. What else? Make sure you know those graphs, right? From the equation to a graph, there's all kinds of them. You got a whole packet on them, right? The cardioid, the dimpled limison, the convex limison, inner loop-de-loop, all kinds of things. So the graphs you'll have to do from an equation, graph it, and you will also need to, given the graph, come up with the equation. Look in the notes. They're fabulous. Yeah. And I think that's it. All of those graphs. Okay. Can you do the last question on the quiz? Yes. And then I think our time will be up after that. Perfect. Yes. Okay. So this is quiz number 16. And it is r equals 2 minus 2 sine of theta. All right, so the 2 and the 2 match, right? Those two numbers are the same. They're the same number, which means it's like your steady heartbeat beating at the same rate. Womp, womp, womp. So it's a cardioid. It means it's the heart-shaped one, but with a rounded butt. Sine means that it's going to be oriented on the y-axis. I'm just going to call it the y-axis. I know in polar we call it the theta equals pi over 2 axis, but whatever. The fact that it is a minus sign here means that it will be below the pole, or south of the pole, south of the origin. The major part of the graph will be. And then my diameter will be 2 plus 2, which is 4, and then the bumps will be at 2 on the other axis, on the x-axis, since our major thing is on the y. All right, so womp, womp. And remember, these would be polar grids, right? But you'll have a point on the pole. You'll go out 2 units for the bumps in those directions, right? And then your diameter was 2 plus 2, so 4. So you would go out 4 units down and south of the pole like that. And then you just connect them. Bump and a bump and meow. Meow. Okay, that was not too shabby, considering I'm using this little tablet thing and it's usually really hard to graph on there. But there you go. That's the last question on the quiz. Okay, I'm calling it a night. We will go over your quizzes and stuff tomorrow, so you still have tomorrow to review. Good luck, and see you tomorrow.